So this talk is just generally structured as problem statement and then how FlyWeb addresses that. So literally everywhere these days, all of you have a smartphone. And between that and your laptops and desktops and the whole smart devices and Internet of Things stuff happening now, we anticipate that the things are everywhere. And getting them to talk to each other, it still isn't easy, right? This is how we share files with each other even today, right? If I, both of us are in the same room, I take a photograph, I'm going to email it to you or put it on my Dropbox and share it with you, or send it on Instagram or Snapchat or whatever. But we're sort of, even though we're in the same room, we leverage the cloud because the solutions aren't really there. And this is how we stream content to other devices. So if I have an Apple TV and I have an iPhone, I can stream to that Apple TV from my iPhone. If I have an Android and a Chromecast, I can stream to my television from my Android. But I can't really use my Android with my Apple TV. There's some sort of third-party programs, but they're not officially supported, and they can sort of stop working at any time. Effectively, the ecosystem of devices and interaction is starting to become verticalized. This is how we build local area experiences. If I want to build, as a developer, a multiplayer game that a bunch of people in the room can play together, games that are designed to kind of be played with people that you're near, the way that I do that is I build an app. I build an Android app and an iOS app, and I go and submit that through the application app store process. I design a protocol that app can communicate through something of my choosing, and then I publish this application. And then on the user side, everybody that wants to play this game, they have to go and say, okay, I'm going to go download this app. Does everybody have this app? If you don't, let's get it. And then everybody starts the app, and it discovers the other players, and you can play it. And if you play for 15 minutes and you want to do something else, use some other piece of software that lets you interact with each other, well, that's another app you download. And you play another game, that's yet another thing. And that friction, is not something that people go through. What happens is people just don't do it. So you don't see games like this, you don't see applications developed like this, because the user experience is just terrible, and so it doesn't happen. This is the other way we build local area experiences. So a good example of this is Google Docs. Like I can create a Google document, send you a link, I send a bunch of people a link, and we can all collaborate on this Google Doc together. This has problems as well. As a developer, if I want to build an application that uses this model where we talk to the internet server and the server coordinates, the problem is first off, there's a liability on my side. Like, I have to host this. I have to put this up on Amazon AWS or Google Cloud or some other hosting, or run my own server. I have to pay for that server. If that server goes down or it gets DDoSed or something happens to it and gets hacked, the application effectively becomes unavailable. And also, oh no, I forgot last one. Sorry, yeah. Oh yeah, right. You don't. This avoids the app issue, right? Like the users don't need to download an app, and they can just visit a URL, and they can do it regardless of what platform they are. But the developer has these constraints, and on the user side, there's other problems. If you don't have an internet connection, you effectively can't use this app. If you're on a cellular internet connection and you're paying by the byte, you have to wonder, like, how much bandwidth am I using? Am I paying for this? How effective am I paying for this? Or what's it going to cost? This is how we're building smart device interaction. So if I, as a manufacturer, am building a quadcopter, and I want to let my users fly it with their phone, I build an app, I go through the same procedure, build it for Android, build it for iOS, ask permission from Google and Android, please let me ship this to my users, and they hopefully say okay, and then each of my users then goes and downloads this app. On the user side, I have to wonder, is this app available? Every time I interact with the device, or the first time I interact with the device, if I don't have this app, I have to download and install this app. And that's okay for devices where you have a strong connection with them. Like if it's your home television or something that you're buying and investing in and going to be using on a daily basis, that makes sense, because there's not going to be a lot of that. But in the future, where there might be hundreds or thousands of these sorts of services that you might come in contact with ephemerally, So you go to a hotel room and there's a smart TV there and it's a different manufacturer from the one that you have at home. Are you going to download the app for that TV? You're not going to be in that hotel room again, and that app is going to clutter your screen. It's going to take up space. It's going to be there when you scroll through your apps looking for things to run. You're not going to run it. The upshot of it is it's just not going to get installed. So that interaction is not going to happen. So for a large class of smart device interactions, this model doesn't really work. It doesn't scale. The user interaction is really poor. And this is yet another way we're building smart device interaction. We take a device, put it up on the internet. This avoids the app issue. The user doesn't have to download an app. They can just coordinate through this internet server. And that sort of works. But again, as a device manufacturer, this causes problems. There's a liability associated with every single product that's shipped. When I ship a physical product, I have to guarantee that there's a server that is fronting that product that is locked. And if that server goes down or if that server gets hacked, my product is bricked for the user. On the user side, there's similar problems. If I don't have internet connection, I can't use my product. If I'm on a slow internet connection or like I'm paying for that internet connection, it's expensive to use my product. If the manufacturer goes out of business, and we've seen this happen with examples like Nest, my product's bricked, right? If I can't interact with this thing, all of a sudden it's a discontinued product, and I'm like, despite the fact that I paid money for it and have it in my home, I can't actually use it because the server is down. And again, if the server gets hacked, the product is bricked. So forcing things to the cloud causes significant problems. Despite the fact that most of the interaction is direct interaction. You're near the device that you want to interact with. We also saw last week that this is a really serious security concern. There was a massive DDoS attack that brought down large chunks of American internet network services because the DDoS was conducted by IoT devices that were hooked up to the internet that got hacked and were used to mount this DDoS attack. So that's just one vector. And if you get something like a camera that's on the internet and it gets hacked, you can go online actually, like this is, and search Google, and you can actually find large chunks of people's unsecured home cameras that you can just watch them, right? Like it's a serious security concern. So there's numerous problems with this. So the upshot of all of this is the futures of cross-device interaction is looking balkanized, controlled by platform vendors that all have their personal platform to push. It's close to interoperability, where you have to think about what smartphone platform you're running, what OS your laptop is running or your desktop is running, to decide whether you can interact with the servers or not. That's starting to, and that's a potential future we could end up seeing ourselves in, where our interaction with the environment around us and how well we can interact with the environment around us depends on our choice of smartphone platform or operating system. And that's not something that I believe is a good thing. It's difficult to develop for because you have to develop for multiple platforms. And you have to sort of, talk to these platform vendors as minimum. They've installed themselves effectively. You can't ship applications to your users anymore if that relationship is no longer a direct relationship. There's a middleman that comes in and says, like, you have to ask me permission if you want to send an application to a user. And ultimately, all of this combines to make it annoying for users to use and difficult, and they're not going to sort of adopt. So the adoption curve is going to be affected by this. We might not see it explicitly, but it's built in. So we can do better. Before, I'm just going to talk a little bit about the web. So in my mind, the web is an incremental, dynamic application streaming technology, right? Every time you visit a web page, you pull down a small piece of an app, and you execute. You pull down some content and some code, and it runs in a sandbox on your computer. And you might disagree. Some people disagree with that being a good thing. They think that the web should be documents, but the reality is the web is an application streaming technology as it stands today. So when you visit gmail.com, your browser becomes an email client. It downloads the code from an email client. And it doesn't download all the code. The first page that you visit, it just downloads the code required to render the user interface to list all your emails. And it's dynamic because the way it downloads code incrementally isn't some static predefined thing. It depends on your actions. If you click on the compose button, it'll download the piece of code required to render the write a new email user interface and send emails back to the server. If you click on a particular message, it'll download the code and content required to render a particular email. So it's a really powerful, flexible application streaming model where a server can send you an application in bits and pieces dynamically in response to the way you use that application, and that leads to sort of very good responsiveness without this pre-investment of downloading an app and downloading all of it and have that code running on your system. The web runtime is cross-platform. Every single operating system you use has an instance of the web runtime on it. It's security hardened, right? And it's not security hardened in some theoretical way where somebody sat down and said, like, we've made this really, really secure. It's security hardened in a way that's fundamentally like production-based. It's been in production and been in use by hundreds of millions of people. It has been attacked. Those attacks have been closed. There have been loopholes found and cracks in the API, cross-site scripting attacks, and the platform has been modified to address those attacks. It's really a security that's been arrived at through a trial by fire. So every single one of you, I'm willing to bet, today downloaded and executed some remote code without thinking twice about it. And that's an amazing thing. That's not something that you really think about too much, but you just pulled down some random code off the internet and you ran it inside your browser and you didn't think twice about all your stuff getting hacked. And that's the kind of security that the web brings that very few other platforms can match because they haven't been tested in that way. They simply haven't, right? This is something that the web has been doing for about 20 years, 30 years. It's really fast, right? So the JavaScript virtual machines that exist today are the fastest dynamic language interpreters and JITs that exist. And then if anybody, like any LuaJIT people want to come and shout at me after the talk, you can do that, but I'm going to make this claim. And between that and ASM.js and WebAssembly, we're really talking about a runtime that can run applications at around native speed, maybe at like a 10%, 20% better. So it's a really fast performant platform. And it's a mature development target. There's multiple implementations by multiple different vendors. There's lots of software frameworks, UI frameworks. There's cross-compilers and trans-compilers and linters and the ecosystem of libraries to build large pieces of software is good, and it's getting better by the minute. So the problem is the web today doesn't let devices talk to each other. A browser only understands how to address things on the internet. So you can give it a URL, and it can go and fetch and stream an application from a server on the internet, but if you're standing next to someone, a browser doesn't know how to address the device that they have. Or if you're standing next to a hardware device, it doesn't have the capability to address that device. And technically, you could maybe write a web server and run it on your phone, and you could tell me your IP address, and I can go and type that IP address into my browser and sort of load stuff. But that's not a user experience that is realistic for any sort of seamless interaction experience. So it's not going to work. But the sort of technical capability is there. We don't need to do a lot to surface it. And so this limitation exists with interacting with smart devices too. The web as a platform is perfectly capable of streaming a control interface from a drone and using a web page to control that drone if the drone is running a web server that serves up its UI. There's nothing fundamentally missing there on the platform level outside of being able to connect these systems, right? That's the fundamental disconnect. So FlyWeb tries to fix that problem, and that's the only major problem we're trying to fix. We're not trying to sort of address, make a grand framework that everything is going to magically work together and you're going to drive into your home and your garage door is going to open, your television is going to switch to your favorite channel. We're not going for this magical futures sort of vision that a lot of people associate with IoT. And I don't like that term personally, like Internet of Things, because it sort of suggests putting everything on the internet. I call them smart devices personally. But we're not going for that grand vision. We're solving a very targeted, simple problem. How do we connect browsers there's this really mature streaming platform to servers that are around you, services that are exposed by either devices or people around you. So it's really simple. So first step is we have smart devices serve their user interface via HTML and HTTP in JavaScript, right? So that's the first step. That's how you present your user interface, control interface via HTTP. Second step, you advertise that interface via some local area advertising protocol. So Bonjour is a very common pre-existing technology that's well supported that lets you advertise services on a local area network. There's good support for it. And so far we haven't really done anything with the browser per se. All of this is stuff you can do completely independently. And actually there's many, for example, any printer UI that it will do is there's an HTTP server and then it'll advertise that HTTP server with Bonjour. So the third step, which is where we actually get to the meat of it, is we want to allow browsers to discover and connect to these servers. So we add a component to the browser, similar to a bookmark list, except it's not filled with bookmarks you made before. It's when you visit that list, it does a discovery, and it shows you here are the things around you that you can connect. Here are the services around you that I've discovered. And when you select one of those things, at that point, everything else just falls back to the pre-existing web platform, right? Like the device sends you a web page. That web page can render like a joystick interface, and it can send you a video stream in that web page from its camera. The web page can make a WebSocket connection back to send sort of low latency control information back. And it could be a different UI too. Like this could actually, instead of giving you a joystick, it could give you, or it could take advantage of the sensor APIs, web APIs on the phone, and maybe you can use your phone as like a steering wheel to control the drone, whatever the developer wants. And that's it. That's all we're trying to do. Except one more thing. So now that we have this idea of being able to advertise a local area web server and then have another browser discover it and connect to it and sort of present the service in that way, another thing FlyWeb proposes is to allow web pages to do this. So have a web page be able to use an API to stand up a local area server that is then consumable by people near you. So this is an example of what that might look like the API, and we've actually implemented this. So Navigator, you call, .publish server, that's the API function. You pass in a name of the server that you want to advertise, that returns a promise that resolves to a server, and on the server object, you just attach an onFetch handler, and that handler gets executed whenever somebody connects to your phone, connects to the service exposed by that web page. Right, so this web page could be loaded on your phone or your laptop or your desktop. It doesn't really matter, but it can sort of throw up this. Here's a local area service, and one or more people near you can connect to you. So, what could we build with that? So I'm going to run a demo here real quick. Hopefully, I don't run into demo issues. So we've actually implemented this in Firefox 90. We've sort of prototyped it. So let's see. Connected to, I'm really wary about using common Wi-Fi networks because they've been a great source of problems. So I'm just connecting to a Wi-Fi network that's hosted by the hotspot on my phone here. So I'm going to visit a web page, right? And this web page happens to be served from my like a server on my computer, but it could be an internet web page. And this thing here is the prompt that's shown by the browser when the web page tries to publish the server. Like it's asking, just like when it tries to get your location, the browser makes sure that the page has your permission to publish the server, because we don't want pages to use this feature without user consent. So I've allowed that to happen. And what we've built here, my colleague built this. This is a Unity game that's compiled to the web. It's like a Mario Kart style game, right? And it's a 4-player game. And this thing is now advertising a FlyWeb server. So now on my phone, I'm connected to the same network here on my phone. I'm going to run Firefox Nightly, and You might not be able to see this, but there's a menu here, and it's discovering the service advertised by this game, and it says FlyWeb GP. It's FlyWeb Grand Prix. This is the name of the game. So I'm going to just select it, and when I select it, this phone is going to connect back to that web page. The web page is serving up a control interface to my phone. This is what that looks like. So I'm going to play it like this. So, and I'm playing. And if one of you wanted to install Firefox 90 on your phone and like do the things to set up support for FlyWeb, then you can come up here, join me, and you'd be player 2, and all 4 or 2 of us or 3 of us or 4 of us can play together. And so the thing I want to point out here is there's no infrastructure here. There's no custom apps. There's no sort of custom protocols or anything. That's a browser running on my laptop. There's a browser running on my phone. These 2 devices can talk to each other. The server that I'm connecting to with this phone is being served by the web page running this game that's loaded by my laptop. And that's it. I can build this game with zero infrastructure, with just the infrastructure that we have already, and the sort of pre-existing technology that we've built with the web and built up to the level that we have. Like, this is leveraging everything that the web has built up so far. It's using as and JS and WebGL to sort of render these accelerated graphics, right? We're using WebSockets to send the control information back in a very low latency way back to this web page. So we're leveraging everything that the web has built up, and we're able to create this experience without any custom apps, without any sort of extra steps to take. So this kind of interaction doesn't have to be laptop to phone. It could be phone to phone. It could be a multiplayer game where you start a multiplayer game, you load it on your phone, on a web page, you start a multiplayer game, and that advertises the FlyWeb service, and 1 or more people join you, discover and connect to you, and they don't have to even know what game they're playing, what the name is. They don't have to think about, can I support this game? Where do I find it on the App Store? What is its name? And so forth. They just discover and connect to you, and you play this game. And then 5 minutes later, you can throw it away, load another game, and they can discover and connect to that, and you can play together, or not a game if it's some sort of other interaction. So one example that I thought of as we were brainstorming use cases for this sort of technology is, let's say, so right now I'm giving this talk, and I have a projector, and I might need a mic if this room was really big. Let's say we didn't have that, and I wanted to give a talk to you. It'd be really neat if I could go to my Google slides page and say advertise this page, like my slides, as a FlyWeb service, and everybody that wants to listen to this talk can connect to that page, discover and connect to it. The page would be coded to send you a view interface to my slides. And as I flip through the slides, it would control your view and flip through the slides for you. So you wouldn't need a projection screen. And the web page on my phone could even use the media APIs on my phone to get my voice and stream that to everybody listening in. So even if there was a sort of a loudness issue and if people couldn't hear, you wouldn't need it. You just plug in your earphones, and we could hold this talk in a park or in a room with zero infrastructure, and then have a conversation. We could even do it in a place where there's people milling about and like people walking through, and we could still have like a clean interaction. So the sort of kinds of applications that we can build with this are pretty sophisticated. So I'm just going to quit this and get back to my talk. So the point of, one of the things I wanted to draw an analogy to here is XHR, XML computer list. The kind of feature we're proposing with FlyWeb and we prototype and implement it isn't huge. Like, we're not doing a giant thing. There's publish server and there's the sort of small discovery component. The amount of code here is actually very, very small. But the impact that it can have is really huge. So the analogy I want to draw is with XHR. And I was working in bioinformatics at NRC in Saskatoon, writing web UIs when this thing happened. Right? Like, this was just like 5, 6, 7 years ago. And before this, like we would present this control interface to scientists where they could see their data, and there was giant, like it was big data before big data became a thing, right? Like these giant sequence databases, which they were querying for information, and there was a lot of information that we could show, and what we would do is, many of you might be familiar with these techniques. You had pages that reloaded themselves on a timer. Every 60 seconds or 30 seconds, they would reload themselves because there's no way to fetch more data from the server. Every time the user would do something on the page and it required some interaction with the server, it would move you to a new page. The interaction was actually terrible. And then XHR came along. It was one API. All it did was let you fetch some data from the server. It was minimal. But the impact that it had was, it was so big that we decided to call it Web 2.0. Like, remember, before that is Web 1.0, and after XHR, there's like all these terms, AJAX, and we called it Web 2.0, and it had rounded corners and really, nice web pages that reacted really well. So it doesn't take a lot, and the reason that this had such a huge impact was because this crossed the bridge. Like XHR didn't bring anything a whole lot on its own. It just sort of allowed the value that had been built up in the web platform. JavaScript existed. It had the ability to manipulate the DOM, stick content in the DOM. All of this existed, but it was siloed because it couldn't access the server. And so you couldn't really build anything sophisticated. So XHR came along and said, like, here's a little missing piece of the puzzle. Now you can leverage all of this stuff and pull some data from the server. And that let us build applications. And then, that was what led to like the initial sort of surge of the web as an application platform. So I feel that the FlyWeb as a feature has that property. That it's not a big feature, but what it allows is it takes the value that's been built up in the web platform that is now currently limited and restricted to only talking to the internet, and changes it to say, okay, well now, like you can also talk to devices near you. You can also just address services around, and that wasn't possible before. So it sort of unleashes that limitation. So where are we at with this? We prototyped this in Firefox nightly. It's just in Firefox nightly because we need a browser to actually implement this on. We don't want to write a browser on our own. We're not shipping it in Firefox or Beta or Aurora or a developer edition. And even on nightly, it's kind of hidden behind a prep. You have to sort of change some settings on it to get it to enable, because it's a very preliminary implementation and there might be security issues. We haven't gone through a full code review. All that stuff still needs to be done. So we have a web page, flyweb.github.io. If you visit there, it'll give you instructions on how to, get it, started on your browser and like what the steps to take to play around with FlyWeb. There's enough of an implementation to do that demo that I just showed you. We have a few other demos. There's some Hello World, and we actually have a GitHub repository of examples that you can follow. The Hello World sort of code, like a simple minimal FlyWeb test case, is just that. That's all the code that you need to sort of get a minimal FlyWeb server. So it's quite easy to get started with. On Twitter at Moss FlyWeb, we have a Slack channel that the web page will give instructions on how to get invited to, and we're on IRC, on the Mozilla IRC server at #FlyWeb. So we just prototyped. It's basically a V0. It's a minimal amount of work, and we've sort of basically stopped doing implementation work on it to validate the idea. So that's the reason I'm giving this talk, and the reason I came here is to put this up as, here's the thing, here's the pitch, right? What do you think? Is there something real here? Because it doesn't make sense to go and spend a whole lot of effort, kind of finishing this feature, completing it, because it's more than just implementation. We have to do a lot of work getting buy-in from Chrome and then other browsers, and then, because Mozilla doesn't do things on its own for the sake of doing them. Like, our fundamental goal is to improve the web platform. So if ultimately this feature is going to end up as a Firefox feature, it's not that interesting to us, right? Like, we want the web to get better, not just Firefox to get better. So, one aspect, one way in which we're eliciting that validation is by asking developers to sort of play with this feature, see what you can build, if you have ideas for applications, phone-to-phone, desktop-to-phone, laptop-to-phone applications that you can build on top of this, we'd love to hear about it. And if you want to just go ahead and start building it yourself, and if there's problems, you can shout at us. That's fine. And that's the sort of feedback we're trying to elicit. And to sort of encourage you to share the idea with other developers. If this is exciting, do you think this is a good idea? Please tell other people about it and see if they're interested. So word of mouth is a pretty big endorsement coming from someone you know. So if you think this is worthwhile, please talk to other people about it. So the thing we're actually working on currently is the development has stopped. We're sort of designing the security features of it. So I mentioned before that printers, for example, already do this, right? Like there's if you buy a printer, it'll have an HTTP service, it'll advertise it on module. There's actually a hidden feature inside Safari that'll let you discover and connect to it. But what happens when you connect to it is the URL that you visit will look something like lexmark.local. Say it's a Lexmark printer. And that causes, there's a problem there, right? Because one of the core security underpinnings of the web is based on names and the stability of names. And the fact that when, let's say I visit gmail.com at time A, at point A, and I visit gmail.com at time B, in point B, the web browser assumes that I'm visiting the same service. And if somehow DNS gets hacked so that someone can insert their own IP address in there, they can actually completely take over that section. If naming is allowed to be sort of messed with, the web security model breaks down, right? So if I visit lexmark.local on network 1, on network 2, if I visit lexmark.local, the browser is going to think that I'm visiting the same conceptual service, but it doesn't have to be. It doesn't even have to be a printer. It could just be some person running a device that's pretending calling itself lexmark.local, and what they can do is they can steal the cookie set by the first page, right? And the whole security model breaks down. Any permissions you've given to that first page, like you gave it access to your location, well, the second page gets it, right? So the web security model breaks down. So we have to answer the question of how do we address naming in this situation where a service you're connecting to needs a name. It doesn't get the name itself. Or if it does get the name itself, it has to do more than just say, I am this thing, right? So answering these questions is sort of a key part of getting this to viability and in production implementation as opposed to just a prototype implementation. Currently, we get around the issue by saying devices can't name themselves. When you connect to one of these services, the browser actually generates a UUID, and that's the name assigned to that service. So the server doesn't get to choose its name. The thing, like the discoverer, the client chooses the name of the server, and then it has a unique name, right? So that we avoid that issue, which is sort of like a really crude way of avoiding that issue in the short term, but in the long term, we want to have meaningful names for these things. We want to have repeatable sessions for these things. So we're working on that. We're also working on the threat model. Like if a page can call a public server and somebody can place an attacker on, and then a hacker can sort of place a listener on your network, can they steal information about you? Can they correlate your presence on this network? Right? Ultimately, the answers to all these might be, well, maybe, but that's not really a big deal, and so forth. But we do have to go through the mechanics of asking these questions about where the security threats are, what the mitigations are, whether they're real, whether they're not, and then sort of, provide an answer to all of that. So that's one of the things we're working on, and one of the things we want to work on shortly is to sort of open the communications channels with other browsers. We have talked with teams in Google, not specifically the browser teams, but we've talked with the physical web team. We've sort of had ongoing communication with them. I don't know if you guys know about physical web. It's a similar, but not quite same technology. And we have a standardization track that we'll need to get through with. That's kind of blocked on the security stuff, sort of being roughly sketched out in the short term. So this is a small team. This is not like a giant project within Mozilla. We're not, it's not like Mozilla's kind of betting on this is the future. It's mostly a thing that we've bootstrapped internally, a few kind of motivated people inside Mozilla, and we've had the support of a lot of people outside of the team, and their encouragement Fundamentally, there's 2 full-timers working on this project. Myself and Justin Arcangelo, who works out of Philadelphia. I work from the Toronto office. And that's it. We're the 2 guys that are pushing this forward right now. And that's the end of my talk. Thank you for listening. I can take any questions. I hope I didn't go over to like 11:40. Not bad at all. Okay. Yeah, thank you. Sir?
First of all, this is fantastic.
Thank you.
Now, you say soon you're going to have talks with other browsers, but you must have had some casual conversations.
It's been brought up. Yeah, there's been like, you know, they're aware we exist. We haven't made a proper pitch to them. You know, sort of, here's, and you want to be careful when you do that, right? Like, you usually don't get, you know, 4 or 5 times to go back to and engage in these things. So you want to have your story straight, and ideally, what we'd like is like uptake and interest from the general development community that works with the web. So hence this one, right? We want to sort of go to them with sort of some response from that community, and as well as sort of potentially some interest from device manufacturers, like the industry, sort of bundle that up. That presents that, okay, there's real interest in this, and that we can, you know, add to our arguments. But here's why it's a good feature. Here's why it makes the web better, and, you know, make that first argument really strong. So because it's like such a small thing, there's, you know, we can't work on 15 at the same time. So we have to prioritize very, very carefully. So before we go, we do need to have the security story well sketched out.
Yeah, mostly I was asking just because somebody else might be working on the same kind of thing.
They may be. It would be like, I know physical web exists, but physical web is not quite the same thing, right? Like it's similar in intent in that it still wants to let you interact with devices around you, but the way physical web goes about it is it's a URL source for the browser. The idea is still that your browser receives a URL, but instead of you typing it in or coming from a bookmark or a link, it comes from a beacon near you or something that's advertised, and then your browser goes to the internet and fetches a web page, and then that web page interacts with the device either directly through like Bluetooth APIs, like web Bluetooth APIs, or through a server that coordinates that interaction and bounces it off to the cloud. So fundamentally, like, I think that's a good idea, and it's a very simple and like crisp design. I personally think that there's value in bringing the web architecture down to cross-device interaction, right? So, for example, if you're building a physical web app and it uses Bluetooth APIs to talk to a device, then really what you're doing is you're building a Bluetooth-based app, right? With FlyWeb, if we can, at some later point, we can add a Bluetooth transport, but the application code doesn't change. It's still just a web thing, and it uses WebSockets and HTTP, and then you just happen to be talking to a server that's near you instead of a server on the internet. But fundamentally, the application stays a web application, and you can use web application, all the libraries and tools and stuff that exist both on the server side and the client side to build these things, which they're pretty sophisticated these days. You can bring them to bear directly on building these applications. Yes.
So just quickly, I just want to know so your browser your phone connected directly to the browser that's running on the laptop without any you didn't have to type anything in, or was that already keyed in before?
There's nothing keyed in. So the only thing that was the prerequisite is they're both on the same Wi-Fi network. And we've explored sort of allowing this to happen over Bluetooth.
So you're still using the Wi-Fi network?
We're using, yeah, so they're on the same Wi-Fi network, and the web page, the server that it starts. So conceptually, the server is associated with the web page. It's run by the browser, but it's tied to the web page called the server. So that server is advertised over on the local network, and the browser on my phone is able to pick that up and show me a list of all of my servers.
Because Because I'm just wondering, like, if you didn't have the Wi-Fi network, and then you had to, like, what would that look like?
So to have something that works in that context, we'd have to look at using transport, or some other non-net network-based connectivity. So that again, that's something we've explored. But the nice thing about Wi-Fi is it exists. It's really prevalent. The hardware support is really solid. Bluetooth, I would say, like Bluetooth LE is impossible. It's like it's not usable for this use case. The bandwidth limitations, like you're talking about, like 3 gig per second, and you can't deliver web content over that meaningfully. So you have to talk about Bluetooth RF anomalies, classic Bluetooth sockets. The problem with classic Bluetooth is the applications that aren't great. Like iOS doesn't have any APIs for apps to YouTube to sort of take Bluetooth sockets. So we have some issues to solve it, but I think we can get there. But yeah, right now you need to get on the same Wi-Fi. There's somebody with a question there, and then after that,
Oh.
there.
So I was gonna. So I first understood without infrastructure to be like not on the same land, they all go out their own ISPs and they're able to talk. That's not really what's happening here.
So infrastructure in the sense that, I mean, you still need some communication medium for these two things to interact.
Right, they could have their own ISPs.
They can have, but I mean, you need, like, so right now, for two devices to talk to each other, either you're looking at Wi-Fi direct, or Bluetooth, or you're on the same LAN.
Well, through the internet and then
Right,
through the other device.
So you don't need to go through the internet. You need to be on the same
LAN. That's okay. All right.
When you were talking, I was thinking about physical web, and then I was interested. You talked about it at the end. I wonder why you're dismissive of it, though, because it seems to me that it would solve your discovery problem without you having to invent so much. I realize you have invented it in Nightly, but the fact that Google's shipping Web Bluetooth in Chrome, why not just be a beacon and like have your browser be a beacon or your device be a beacon that sends a URL out? And like I agree, the zero config style Bonjour thing is really elegant, but I mean I'm just thinking about things that exist.
I'm not dismissive of Google. I think it's a great idea, but I think it's different from what we're doing. So, and I think like. It's certainly possible to imagine, both of these projects kind of being two different, approaches to addressing the same issue with different trade-offs. Where, in one sense, you can imagine physical web as the discovery layer for FlyWeb.
Right.
Or you can imagine FlyWeb as physical web plus the for you to get the page from the thing that you got, that's advertising inside getting the page. Right, so you can sort of, look at it in either way and think about these two things together. But I think that the differentiation for me is that that we really bring to bear the specific web architecture down onto the cross-device interaction.
But if Web Bluetooth is there, again, I'm with you because Bluetooth has not been part of the web up till now. But with Web Bluetooth, it's going to be in the same way that XHR became, WebSockets became, like, et cetera, et cetera.
So there's a little bit of, I think there's certain things that aren't right. So for example, if I'm fetching like a page, if the control interface that I'm fetching from this server, let's say like a drone or whatever, right? The way I implement, say, a streaming video on my phone or whatever device I'm using to control this thing is a video tag, right? Like the level of browser abstraction that's brought to bear on, like, and it's a video tag, and that implicitly says the browser goes back and fetches the content from that thing and like streams it as a video here. If you're doing that over a custom Bluetooth API, what you're then doing is, it's not a video tag anymore. It's, you put a canvas up and then you back that up with like some library that talks over Bluetooth. So
yeah, that's ridiculous. I agree. I'm just talking about the discovery of the URL. No, I think you still need the HTTP network. You still want the infrastructure of the web. but as a way to, like, the reason I'm pushing it is, my fear for what you're doing, I think this is amazing. I'm a longtime Mozilla developer, so don't hear anything negative in what I'm about to say. But I think it's hard to imagine Firefox on mobile getting this done, because ostensibly it is an app you have to download. Like, people aren't running it on their phones. Whereas if you can leverage infrastructure that Chrome is shipping, I realize that, like, in some ways, your fastest way to get this done would be to implement this in Chrome. Like, it sounds ridiculous, I know, to say, oh, Mozilla should be off, but if you want to really push the web platform, you almost should put a feature flag up in Chrome and try and get that patch landed, because
I don't disagree at all.
Yeah.
Like, this has come up significantly. It's not something we can push through Firefox on.
like on desktop, I think it was
absolutely
possible to do it, but it's hard on mobile.
So, I mean, there's been a few ideas discussed. One is we can actually, we can build standalone apps to do this, like sort of wrap up the web view. We can potentially look at implementing it as a Chrome extension. The problem there is I don't think Chrome extensions run on Chrome for Android. I don't think they're supported. So we can do that for desktop, but we can't do it for Android so much. And the other thing is just sort of do the implementation on Chrome. But again, fundamentally, we don't want to take the step of really pushing forward with this without like this validation step and the security thing. There's a few things we're blocking. Like the security thing, we got to figure out the answer there. And there is an answer. It's just we got to find it and like document what that answer is. So that's a process we're going through. That plus community validation and industry validation as this is a thing that makes sense. And then once we get all that back and process it over the next sort of month or two, we have this big all hands happening in December. So that's sort of the next sort of milestone or junction point, like forcing function. At that point, we'll figure out where we at, how much resources do we love, more resources, or allocate more resources, or figure out how to move forward. So we could just like any of these. So yeah, thanks for that.
Anyway, it's great.
All right, Kannan, thank you very much.